Okay, so the figure is made up of a rectangle and a square. Ratio of the area of the square to the area of the rectangle is 2 to 7. Okay, and then they tell you shaded area is 4 cm square. So straight away when you get the shaded area is 4, you straight away annotate it on your diagram here. Okay, so ratio square to rectangle, I'll write that down first. 4 cm square, I will annotate it on this shaded part. Okay, so record all your data out first. Now, then moving on, the ratio of the unshaded square to the unshaded rectangle is 3:13. So you see you have another ratio here. Now in this case, this 3:13 is referring to unshaded square, unshaded rectangle. So what you can do is,
UN. Yeah.
you can write UN, no problem. Or you can just write bracket U, then the square, bracket U, rectangle. Up to you, you write UN square also can. Okay, so long as it's very clear to me that it's the unshaded ratio. Okay, so now they ask you for the area of the figure. Now remember we have two ratios here, right? So what must we do first?
Find the common base.
Correct. You must always find the common base first. Okay. Now in this case, right, is there any clear common base between the these two ratios?
No.
No, right? No common base. Okay. So actually, yes, there is no common base between these two. But because you realize that they are both sharing what? They are both sharing the same shaded part. Okay, so what I can do is I can actually join up these two ratios to form a before change and after. How are we going to do that? Okay, so the next thing I'm going to show you is this. I will write out a change here. I hope you all have space for this to write out the change. Okay, now from this, let's focus on the square first. For the square to become unshaded square, for a whole square to become unshaded square, what must be removed? For the whole square to become just the unshaded part, what else must be removed?
Oh no.
The shaded part, right? Correct.
Oh.
Whole square minus away shaded part give you the unshaded square. Make
Oh
sense?
yeah. I always remember you teaching me like must remove that part or something.
We did this in one of the practice review class, if you recall. Okay, so in this case, shaded square, I'll put minus 4 cm square. Since I already know shaded is 4 cm square, so I put minus 4 here. Please label this as SH, bracket SH square.
Now it's the BCA.
BCA, no, BCA is only when the change involves a fraction, ma.
Oh.
Alright, this one involves a whole number, so there is no, you can't change this 4 to BCA, ma. 4 is just a whole number, absolute number. Okay, so now the next thing is, let's look at the rectangle. Focus on just the rectangle. Again, same thing. Rectangle, you must minus away something to give you just the unshaded part.
The shaded part.
Correct. You must also minus away the shaded part of the rectangle, which is also 4 cm square. You see, this is how I join up these two sets of ratio. Even though there was no common base at first, but I can actually join this up, okay, to check later on, is there any common base that I can come up with. Now, what do you realize about these two values?
They both minus 4.
They both minus 4. So you see, when the changes for both groups involve the same value, what remains unchanged throughout?
Wait. Difference?
The rectangle.
Just now, Peng, you say difference?
Yeah.
Yeah, it's the difference that remains unchanged. Declan, correct? Because now the change involved same numbers for these two groups. Remember, like for example, they say I take out equal amount of rice from each bag. So it's something, if I take out same amount of rice from each bag, both bags difference will remain unchanged. So it's the same idea here. So I can make the difference. Okay, I can create a new common base, which is the difference here, 5 units, because 7 minus 2. Whereas the difference here is 13 minus 3, which is 10. So of course, don't stop there. Okay, proceed to make your difference the same. Then underline the common base. Up to here, you're okay first? Okay, so now you see this whole question, right? The whole question here, we can only start use the 4 cm square to find out how many units is 4 cm square. Correct or not? Okay, so you can look at the change. The 4 is the change. So you either use the square or the rectangle to find the change in units. Okay, so what's the change? What's the shaded part units here? So remember just now I say square minus shaded give you unshaded. So what can I do with the 4 and the 3 here?
4 minus 3, then you get 4 cm2. 4 cm
Square.
square, yeah. Square.
Correct. Okay, 4u minus 3u. So that shaded part will be 4u minus 3u. Or you can actually take 14u minus 13u using the rectangle also can. Okay, you still get 1 unit. So what does that tell you about this 1 unit?
It's 4 cm square.
4 cm square. Very good. Okay, so you see 1 unit done. You have the value of 1 unit. Then from there, okay, it's actually easier to solve already. So now the question asks for the area of the figure. So if you notice, the area of the figure consists of both the unshaded and the shaded one. Now, since I already know shaded is 4 cm square, so now we should be concerned with the unshaded parts. So unshaded units, how many units altogether?
Unshaded is 16.
Very good. How you get 16?
13 plus 3.
Very good. 13u plus 3u here. Okay, so unshaded units is 16 units. So of course, you go and find the area of the unshaded parts, which is 64. So then from here, what else must I do?
Area of the figures.
This is just the unshaded area, right? So now you want the area of the whole figure. Is it just the unshaded?
No, plus the shaded.
Correct. You got to plus back the shaded. Okay, so you got to take 64 plus the 4. Okay, so for this question, common base, okay, might be a bit more challenging to see. Okay, but just observe that, okay, if they share the same common shaded part, you can actually use this as the change over here to join them up.